In this animation, we'll give some intuition as to why the profit function is convex in prices, and in the process we'll see some intuition for Hotelling's lemma emerging. We'll do this in the context of a single input production process, but the intuition offered here holds exactly the same way for multiple input production processes. We begin with a production function that gives rise to a convex producer choice set and a wage WA and an output price PA, such that A is the profit maximizing production plan. If the price of the output increases, then the slopes of the isoprofit lines will become shallower. This implies that even if the producer remains at the production plan A, his profit will increase. He will simply sell what he's producing at a higher price, thus increasing revenues without changing costs. This can be seen in the vertical intercept of the dashed green isoprofit line that has the new slope but continues to pass through production plan A. Of course, a profit maximizing producer will not remain at production plan A, but it will instead shift to a higher isoprofit line that is tangent to the production frontier. This is illustrated here with the magenta isoprofit line that's parallel to the dashed green line, but is tangent at the production plan B. Since the isoprofit is higher, profit goes up as a result of the producer's change in behavior. We'll next transfer some of the information from panel A into panel B, where we put output price on the horizontal axis and dollars measuring profit on the vertical axis. For the initial price PA, we can then illustrate the level of profit that the producer attained. When price goes up to PB and the producer does not change his production plan, his profit goes to pi prime, indicated by the green dot. Profit is equal to price times output minus wage times labor. If we hold the production plan fixed at XA and LA, and we hold the wage fixed at WA, then profit is equal to P times XA minus WA times LA. In other words, we get an equation for a line that has a negative intercept of WA times LA and a slope of XA. This is what we might call a naive profit function that assumes that the producer will always use the production plan A no matter what happens to output price. A profit maximizing producer is of course not naive and will not continue to produce at the production plan A when the price goes up. Instead, as we showed in panel A, he will switch to the new tangency at B. At production plan B, his profit is higher than pi prime, as indicated by the point B prime in panel B of our graph. Just as a profit maximizing producer will do better than a naive producer who always uses production plan A, when the price increases to PB, he'll do better no matter what happens to the price, and therefore the actual profit function will lie above the naive profit function in the way indicated here. The further the price deviates from PA, the better the profit maximizing producer will do relative to the naive producer who always produces at production plan A. The only time that they will do equally well is if the price is PA, where the profit maximizing production plan is in fact A. If the output price falls to PC, for instance, the naive producer who uses production plan A will make a negative profit, but our sophisticated profit maximizing producer will still earn a positive profit. We can easily see then that the actual profit function has to be convex in prices, because the naive profit function is linear in prices, and the profit maximizing producer will do better than the naive producer, except for the one price at which the naive producer's production plan is in fact the profit maximizing plan. We can also see Hotelling's lemma emerge in panel B of our graph. Hotelling's lemma says that the derivative of the profit function with respect to output price is equal to the output supply function. Here, the derivative of the slice of the profit function at A prime is equal to XA. XA is the amount of output supplied at price PA. We can generalize from this that the derivative of the actual profit function must be the output supply function, because at each point on the profit function there is a tangency, and each of those tangencies has a line associated with it that's equal to the naive profit function for a producer who is producing a particular production plan. In panel A, we happen to start with an initial price PA and the profit maximizing production plan A, but we could have started with any other price and found the initially profit maximizing production plan, and that would have then given us a different naive profit function that then creates the tangency in panel B. The actual profit function is therefore really the upper envelope of lots of naive profit functions for different price levels and different associated production plans.